And COVID pandemic has only accelerated that digital transformation. The increased reliance on the web, the internet, for all services. Whether the way we shop, the way we study, the way we see the doctor, the way we communicate, probably everything has been impacted by this digital transformation, of which the backbone is the internet. And the internet is nothing but a huge, a massive distributed system, right? So the internet is such a huge distributed systems, and there are people, billions of people all across the world, globe, who are connecting through various devices. It's not one device. You're connecting through your mobile phone, you're connecting through your computer to your tablet, you may be communicating or connecting through your watch, you may be connecting through smart spectacles or clothes, whatever be the case. So the internet itself is a massive distributed system, and that is, if you take an intranet also, inside the institution or inside the company, that is also kind of a distributed system. It's connected to the internet, it has its protocols. So every network will have its own internal arrangements. Internet is a massive distributed system, billions and billions of devices are connected. Likewise, inside your organization there is an intranet. Inside the intranet there are some policies, there are some ways to restrict the entry. For certain things you need internal people alone to have some sort of communication and collaboration. You have a firewall that is there between your intranet and the web internet outside, and the firewall does kind of a filtering. It has its own security policies. It ensures that the right, whatever comes from outside, there is some sort of logic, there is some sort of policy whereby we accept. It is like a border pass, anything that comes inside and so on. And the firewall takes care of everything, in the sense that it acts like a barrier between your intranet, which is again a distributed system, and the massive internet, which is also a distributed system. So what is a distributed system? Distributed system means it's basically a collection of autonomous computers which are connected through a network, and there is some sort of middleware which results in the coordination and the collaboration and the other activities. So basically, it's the computers are autonomous, they are more or less independent, they are connected to each other, but they have some sort of process by which they are able to share resources, they are able to talk to each other, communicate with each other, they are able to collaborate with each other, and they act in such a way that they are one unit, one integrated unit. So just to give you an example, see, you may be sitting in Trivandrum, you may be sitting in Rajamundry, you may be sitting in Delhi, and you are trying to access the university network. So the university network, you access it, the whole university network is like it's a single unit for you, because you are not accessing the computer in computer lab 1, or you are not accessing the computer in mathematics department. You are going through a system where you are trying to connect through the university network, and the university network as a whole is like one integrated unit. So as far as you are concerned, you are trying to connect to the university network, which is an integrated unit. It is another thing that there are probably 2500 plus computers on that network, maybe more, but for you it is one integrated computing facility. So that's the idea of the distributed system. So distributed system, internet is a distributed system, intranet is a distributed system, A distributed system means they are autonomous computers. Each computer is capable of independent existence, but they are all connected together. They collaborate with each other. They communicate with each other. And there is some logic by which they share the resources. They talk to each other and they act as if they are one single network. This is the idea of the distributed system, and that also means that they can concurrently work. They can work in parallel. That's what I was trying to tell you, that parallel computing is only a type of distributed computing. They are working in parallel. If one computer in the network conks off or switches off, it's fine, the others will work, the others will take over. So this kind of story is there for a distributed system. Now, as I mentioned, entire world, the internet is a distributed system. Every single huge network, huge application, works on distributed networks. If you take a finance and e-commerce, Amazon or eBay, PayPal, they're all running on distributed systems. Wikipedia, social networking. In the last course itself, I told you, today Facebook is 2.6 billion people. All 2.6 billion people are in all 200 plus countries throughout the world. And they are all connecting to each other. They are sharing information, liking information, and so on. So there is probably no industry, no vertical that has not been affected, whether it is gaming, whether it is social media, whether it is healthcare, whether it is education, transport, logistics, science and technology, research, environment. Everything is the backbone, so as to speak, like the internet, runs on distributed systems. So if you take examples, e-learning networks like Udemy or whatever, MIT OpenCourseWare, healthcare healthcare networks, entertainment networks, YouTube or Flickr, Google Maps, Google Earth, transport, logistics. Every single industry, the backbone of this is the distributed system, just like the internet. So let's just see how this whole thing pans out. So you have an intranet that is within. This could be Amrita campus. This could be Krishna campus. Probably both Amrita and Krishna are connected through one internet service provider, ISP, like say BSNL. See how this may be the border for the Coimbatore city. This may be Chennai, this may be Hyderabad. So see that everything, the internet is a massive network encompassing everything and anything. The backbone of the internet is distributed system, and see how these distributed systems. So rather I can say that, the internet is only a super network of distributed systems. Everywhere it is distributed across the world. You have already learned about cloud. Cloud is another example of a distributed system being used for several things, several efficient activities. As you know, in a cloud, you have software as a service, you have hardware as a service, you have application as a service, you have computer storage as a service. There are so many thin clients. The client may not have too much of memory. The client or may not have too much of processing power. The client may not even have any software installed except the operating system. But as and when the client wants, it goes to the cloud. It wants MS Word, it goes to the cloud and takes the MS Word, uses the MS Word and returns it. The client wants to store a big video file, it goes to the cloud, takes the storage, puts it on the storage, keeps it there, and as and when required, it retrieves it. The client wants some sort of MATLAB or Skylab, they want to use it, goes to the cloud and takes it. So even this cloud computing setup is probably an extended or a very efficient version of distributed systems. As I told, distributed system is the engine that the engine that drives the internet, so as to speak. Now, I already told you that some specific characteristics of I'll first start with the common characteristics. I'll start with the characteristics of distributed systems. As I mentioned, multiple autonomous computers or components. The computer in your intranet is a part of a distributed system. The computer in the Dhanalakshmi Bank extension counter is part of the distributed system. So the multiple autonomous systems, these systems are all capable of independently working, but they are connected together. All components are not shared by all users. I don't need I don't need the Dhanalakshmi Bank banking application. I'm not going to use that at all. I don't need to get to the bank network. Likewise, the bank does not need to get into the AUMS network. I do not need to get into the hostel network. I'm not involved in any way in the hostels. So there are components that are not shared by all users. There are components that are selectively available for users. You can have policies, you can have rules and regulations to share components, share resources, restrict usage of components, restrict usage of resources. You have multiple points of control. You have multiple points of failure. All of them are working parallelly, independently, concurrently. They need not be in the same processor. They can be multiple processors. I use a Microsoft Surface. The Surface is connected to the internet through the campus network. You may be using, the bank may be using a Pentium machine. It doesn't matter. All these are running parallelly. I may have MS Teams in my computer that is connecting to the server in the campus, but the person in the Dhanalakshmi Bank will not be needing MS Teams for all that I know. So these are some of the characteristics of distributed systems. They are autonomous. They have components and resources. The resources may be shared or may not be shared. You can restrict access. You can give access. You have multiple points of control. You have multiple points of failure. You have software that runs in different processes, different concurrent processes. They can work in different processes. All these are characteristics, and there is no global clock. There is no heartbeat. Everybody works at their own pace, at their own speed, at their own resources. Some common characteristics also, because of distributed computing, a lot of advantages are there. The common characteristics you can even say that they are huge advantages. One is resource sharing. You have cloud, you have client server mechanisms, you have OOPS, you can share resources. I don't need to have MS Teams with me. Everybody in the campus can access the MS Teams in the server and use it. I can be sitting at home and I can connect through my Apple phone and take classes using the MS Teams. The distributed systems are open. People can just join. I want to add somebody. I just call the person and say that add this IP address, and that person can also join onto the network. There is concurrency. Things can happen in parallel. There is scalability. Number of users can be increased dramatically, and fault tolerance. If one thing fails, the other thing will take over. It doesn't matter. There is much better resilience and fault tolerance. And finally, transparency. As far as you are concerned, you are seeing the Amrita network. You don't bother who is inside, how many computers are inside, how many people are inside, all those things. So having said that, there are many common characteristics which become highly advantageous for all of us using distributed systems, which includes resource sharing, openness, adding people, concurrency, parallel working, scalability, adding users, fault tolerance, resilience, and transparency. So these are some of the advantages, so as to speak, of distributed systems. So distributed systems is the backbone of the internet. I will close for today. I will take transparencies in the next class. Can you please answer your attendance? Abhilash, Akash, Amit. Abhilash, Akash, and Amit, please raise your hands. Abhilash, Abhilash, okay. Brijesh Chandra, Chamruta, Dharinish, okay. Dheera Shaji, Aditya, Divya, Emil Joseph, Gajapati, Hari Krishna,